What if the silence of the universe is not emptiness at all, but a whisper too faint for human ears? When the James Webb Space Telescope unfurled its golden mirrors in the cold of space, it was built to chase ancient light. Its purpose was to glimpse the first galaxies, to reach across 13 billion years and touch the edge of cosmic dawn. Yet in the process of looking back, it began to look sideways, toward the stars that still burn in our time, and toward the planets that circle them like hidden jewels. Webb's infrared vision is unlike any before it. Where human eyes see darkness, it reads the faintest warmth. As starlight filters through the atmosphere of a distant planet, Webb can separate its colors, decode its fingerprints, and reveal the gases that wrap that alien world. Hydrogen, oxygen, methane, carbon dioxide each leaves a mark in the spectrum. A silent testimony of chemistry, perhaps even of life. Then came the night when a star dimmed ever so slightly as a planet passed before it. Transit, as astronomers call it, small and delicate, but written into the light with precision. Webb's instruments recorded it, broke it down, and what they found made seasoned scientists pause in awe. The data carried a story almost too bold to believe. It's a world orbiting a quiet sun-like star where the balance of elements was neither barren nor chaotic, but suggestive, almost deliberate. In dimly lit rooms across Earth, researchers leaned closer. To their screens, some whispered, some doubted, yet all of them knew they were seeing something extraordinary. A planet that might not be just a planet, but a place where life itself could be waiting. In the quiet corridors of observatories, discoveries are often born in silence. A faint line on a graph, a subtle curve in data, numbers that to the untrained eye seem meaningless, but to a scientist's whisper of revolutions. When the light from this new world was first broken apart by the James Webb Space Telescope, it was nothing more than a series of dips and rises in a spectral line. Yet within those fragile signatures lay a secret so immense it shook the foundations of modern astronomy. For decades, the search for exoplanets had painted a universe of disappointment and wonder in equal measure. Thousands of worlds were found, but most belonged to strange categories. Giant planets hugging their stars in blistering orbits, scorched rocks tidally locked, one face forever frozen, the other in eternal fire. Distant gas titans with crushing pressures and poisonous skies. Worlds that bore the name of planets, yet carried little of the promise of Earth. Scientists cataloged them dutifully, marveling at their diversity, but quietly bracing themselves against the creeping thought that habitable worlds may be rare, fragile, or hidden beyond reach. Then came this planet. Small, terrestrial, its orbit traced with a rhythm so familiar it echoed the cadence of Earth's year. The data suggested it lay within the fabled habitable zone, where starlight warmed without burning, where oceans could rest in liquid form, where atmospheres might breathe. But habitability alone was not the shock. Habitability is a potential, a canvas awaiting paint. What Webb revealed went further, deeper, almost defiant in its atmosphere, for gases sang together. Oxygen, methane, carbon dioxide, and water vapor. Not scattered randomly, not balanced in sterile equilibrium, but in tension with one another. In chemistry, such disequilibrium is a telltale sign. Oxygen should vanish quickly in the presence of methane, yet both persisted. Water vapor danced above, and carbon dioxide, the breath of volcanoes and oceans alike, threaded through it. Together they formed a chorus that on Earth is driven by biology, by forests and microbes, oceans and animals, endlessly reshaping. The air to quantify the significance, scientists turned to their models. They compared this data against thousands of possible scenarios, testing whether geology, volcanism, or photochemistry could mimic such a mixture. Again and again, the probabilities narrowed. At last, the numbers converged on a staggering result. A 99.7% chance that the signals pointed not to barren chemistry, but to life. It is difficult to describe what such a number means. Science does not deal in absolutes. It speaks in likelihoods, in margins of error. 99.7% is not certainty, but it is a threshold that commands attention. In medicine, such a probability would warrant action. In physics, it would hint at a new law. Here in the search for life, it was enough to ignite a global shiver. The astonishment did not come merely from the data, but from how violently it broke the pattern. For years, astronomers had wrestled with the paradox of abundance and silence. The galaxy teems with stars, most host planets. By sheer probability, some should resemble Earth. Yet each time humanity looked, what it found were inhospitable worlds. Hot Jupiters, barren rocks, frozen wastelands. It became a kind of unspoken comfort. The universe might be vast, but perhaps Earth was still unique. The great silence, as Enrico Fermi once framed it, remained intact. If life was out there, it hid well, but now a planet had emerged from that silence. Whispering of oceans, of clouds, of the fragile machinery of biology. It was not shouting with radio signals or laser beacons. It was speaking in chemistry, the language of breath and decay, of photosynthesis and metabolism. In its thin veil of gases, the possibility of another biosphere revealed itself. The implications rippled outward. If life could arise there, it could arise elsewhere. If Webb, in its first years of operation, stumbled upon such a world, then perhaps life is not a rare accident, but a common consequence of starlight and time. The shock was not only scientific, it was existential. In universities and research centers, debates flared. Could exotic geologies mimic these patterns? Could unknown photochemical reactions trick Webb's instruments? Some pointed to Titan's Saturn's moon, where methane and nitrogen formed strange balances without life. Others argued that Earth-like disequilibrium was too precise to dismiss. The atmosphere seemed alive, restless, constantly renewed by processes that, on our world, are inseparable from biology. What made the finding more haunting was its silence. Radio telescopes turned toward the star, scanning for signals. None came. The sky remained mute. A planet that seemed alive, yet gave no sign of civilization. The contradiction deepened the shock. For some, this silence was reassuring. It meant the discovery was microbial, not monumental. Life, perhaps, but simple life, invisible to the cosmos, safe in its oceans. For others, it was unnerving. If the universe is filled with life, but all of it is silent, then the silence itself is a message. Intelligence may be rare, or worse. Intelligence may be fragile, fleeting, unable to survive long enough to bridge the stars. The philosophical weight pressed heavily. Humanity has lived with the assumption of solitude. Religions, cultures, and sciences were shaped in the absence of cosmic neighbors. Now, a sliver of probability threatened to undo that solitude. Not in myths or conjecture, but in numbers, in gases, in light. The telescope, built to read the afterglow of creation, had become a mirror, showing us not only what was, but what may be waiting. Scientists tried to hold back the tide. They spoke with caution, with phrases like strong candidate, possible biosignatures, further confirmation required. Yet the public heard the deeper note, 99.7%. A figure that sang louder than caution could whisper. In the weeks that followed, the shock turned into a kind of collective wonder. Newspapers spoke of second Earth's artists, painted alien oceans. The world looked up more often, wondering whether in the glow of that star, creatures looked back. It was not proof, not yet, but it was the closest humanity had ever come. Still, the scientific community held to its discipline. They remembered the lessons of history, when canals on Mars turned to illusions. When Venus's clouds promised paradise, but revealed poison, skepticism became their shield. And yet, beneath the surface of caution, they too felt it, the tremor of something vast, perhaps even inevitable. The planet stood as a challenge, both to science and to philosophy. It dared humanity to imagine a universe not barren but fertile. It collided with the great silence, not with noise, but with chemistry, with the silent mathematics of probability, and so the shock lingered, suspended between awe and doubt. a planet ordinary in size, modest in orbit, yet carrying within its gases the possibility of another genesis. A reminder that the most profound revelations of the cosmos often arrive quietly, not in thunder, but in a whisper written into light. The first glimpse of a distant world is never a photograph. It is not a landscape seen through a telescope, nor a silhouette framed against a star. It is light, fragile, ancient, bent across the void, and it is numbers written into spectra. For the James Webb Space Telescope, discovery does not arrive as an image, but as a pattern. A star dims, its brightness shifts, the colors of its light are broken apart, revealing hidden fingerprints. And within those spectral lines, a planet begins to speak. The world that drew such attention was not found in a single night of observation. Its presence was confirmed through patience, through repetition, through Webb's relentless eyes returning again and again to the same star, waiting for the planet to cross its face. Each transit, each delicate dip in starlight gave scientists another chance to measure the thin veil of atmosphere that clung to its surface. And each time, the data deepened the mystery. Webb's near-infrared spectrograph, with its precision etched into polished gold, dissected the starlight that passed through the planet's sky. Molecules in that atmosphere absorbed certain wavelengths, leaving gaps in the spectrum, gaps that spoke of their presence. Water vapor appeared first, unmistakable, traced by its unique absorption features. Then came methane, its signature overlapping with carbon dioxide. Finally, a whisper of oxygen, faint but persistent, weaving through the data like the ghost of a forest unseen. On Earth, this combination would be ordinary. Oceans exhale, water vapor, methane seeps from wetlands and living creatures. Carbon dioxide rises from volcanoes, from oceans, from breath. Oxygen is sustained by the green shimmer of photosynthesis. Together, they form the rhythm of a living world. But to find them together, balanced in disequilibrium, circling a distant star, was to hear a chord played across the galaxy. Scientists knew the dangers of premature wonder. False positives lurk in the cosmos. Methane can be birthed by geology. Alone, its molecules forged in the deep fractures of a planet's crust. Carbon dioxide can rise in massive quantities from volcanic eruptions, sculpting skies without a trace of biology. Even oxygen, the great signature of life, can emerge through photolysis, the breaking of water molecules under the harsh glare of starlight, leaving oxygen behind as hydrogen escapes to space. For every signal Webb detected, counter-explanations had to be tested. Could volcanic activity account for the balance of gases? Could methane and carbon dioxide reach harmony without biology's hand? Could water vapor be a transient artifact, a passing storm rather than an ocean's breath? Teams around the world constructed models, each more detailed than the last, simulating atmospheres under different conditions, probing the chemistry of alien skies. The timeline of confirmation stretched across months. Webb watched not once, but many times, waiting for the planet to reveal itself in different seasons of its orbit. Each transit added precision, narrowing the margin of error. The near-infrared imager and slitless spectrograph added its voice to the data, confirming features that no single instrument alone could claim. Independent teams, continents apart, ran their own analyses, sometimes reaching different conclusions, sometimes clashing over the faintness of oxygen's trace or the exact ratio of methane to carbon dioxide. Yet as results converged, confidence grew. In science, skepticism is not the enemy of discovery. It is the crucible in which truth is forged. Webb's findings were tested against every known deception the cosmos could offer. Abiotic methane was modeled in dozens of ways. Photochemical reactions were stretched to their limits. Still, the mixture resisted a purely lifeless explanation. Gases were not just present. They were persistent, stable across time, renewing themselves against the natural decay that should have erased them. It was this persistence that struck the deepest chord. On Earth, life is not a momentary spark, but a continuous engine, tirelessly renewing the atmosphere. Forests and plankton exhale oxygen as fast as it is consumed. Microbes recycle methane, carbon, nitrogen. Without biology, Earth's air would collapse into equilibrium within centuries. Disequilibrium is the signature of life's ongoing struggle against entropy, a refusal to settle, a system forever out of balance yet enduring. To see such disequilibrium etched into the spectrum of a distant world was to see the shadow of that same struggle elsewhere. Still, caution remained. The distances involved are cruel. Light that reached Webb had traveled for years, perhaps decades, before striking its mirrors. It carried no images of oceans, no photographs of forests, only spectra, only the language of molecules. Scientists spoke carefully, using words like candidate, probable, strongly suggestive. But beneath the precision of their caution ran a current of awe. For here was a planet that, in silence, seemed to breathe. The investigation deepened into philosophy as much as chemistry. If life could alter an atmosphere so far away, what form might it take? Would its oceans cradle microbial mats, as Earth's once did billions of years ago? Would its skies shimmer with the exhalations of primitive photosynthesis, painting the air with oxygen not for intelligence but for survival? Or could it be something stranger, alien metabolisms, shaping gases? In ways we cannot yet imagine, processes unknown to Earth, but still undeniably alive? Each new observation brought humanity closer to the edge of certainty, but also deeper into mystery. Webb's golden mirrors, drifting silently 1,000,000 miles from Earth, became more than tools of measurement. They became storytellers, pulling threads of light across space and weaving them into a narrative that forced humanity to confront its own place in the cosmos. And so the investigation continued. Rigorous, cautious, yet filled with wonder. No single signal was allowed to stand alone. Every detection was checked, every possibility tested, every alternative weighed. The work was slow, demanding, at times frustrating, yet that is the nature of truth when written in starlight. It does not shout, it whispers, and only by listening carefully, again and again, can humanity hope to hear it clearly. The effort to separate illusion from evidence became more than a scientific exercise. It became a meditation on humility. For in the search for life, humans are both explorers and children, reaching into the dark with fragile instruments, hoping that somewhere, in the endless silence, another world has dared to breathe. Science often moves in increments. Discovery is made, checked, revised, and placed into the grand ledger of knowledge with cautious handwriting. But every so often, a result emerges that resists the comfort of caution, that refuses to be smoothed into the ordinary. Such was the case with this planet, where each round of analysis brought not relief, but mounting tension. The first observation hinted at water vapor, the most familiar companion of habitability. The second showed methane layered against carbon dioxide. By the third, the whisper of oxygen had returned, faint but undeniable, weaving into the spectrum like a thread that could not be pulled loose. When models were run against these data, the probabilities sharpened, converging on a staggering conclusion, a 99.7% likelihood that the observed chemistry could not be explained by lifeless processes alone. 99.7%. To the untrained ear, it sounds like certainty. Yet in the language of science, it is something more subtle and perhaps more profound. It is the threshold where chance is reduced to a murmur, where doubt remains only as a shadow. Doubt. In particle physics, the discovery of the Higgs boson was claimed at 5 sigma, a statistical confidence of 1 in 3.5 million. In biology and astronomy, the margins are not as sharp, but the meaning is just as weighty. To stand at 99.7% is to gaze at the edge of belief, knowing that one more step may change everything. But alongside the wonder came a paradox. For while the planet's atmosphere sang with the rhythms of life, its skies remained mute in every other respect. No radio beacons pierced the void, no structured pulses betrayed the hand of intelligence. Sensitive arrays, from Arecibo's successors to the Allen telescope array, turned their ears toward the star and found nothing but the faint hiss of natural cosmic noise. The contradiction was unsettling. A planet that appeared alive, yet silent. On Earth, life reshaped the atmosphere long before intelligence arose. Microbes alone painted the sky with oxygen 2 billion years before humanity learned to send signals into space. Perhaps this planet, too, was caught in its microbial dawn. Alive but voiceless. Yet the silence provoked deeper unease. If life was nearly certain, why was intelligence absent? The question sharpened an ancient riddle, the Fermi paradox. If the universe is teeming with habitable worlds, why has it not teemed with voices? Now the paradox stood not as abstraction, but as data. Here was a world that seemed to breathe, yet kept its secrets locked away. Some scientists took comfort in the simplest answer. Life might be common, but intelligence may be rare and improbable. Flowering on the tree of evolution, for billions of years, Earth itself was filled with nothing more complex than microbes, oceans alive with cells too small to see. Perhaps this planet was no different, an echo of Earth's own prehistory, vibrant with life but not with thought. Others wondered if the silence was deliberate. Intelligence might not be rare, but cautious. Civilizations could learn that to broadcast into the void is to invite danger, so they turned inward, choosing secrecy over contact. The absence of beacons could be a choice, a universal law of survival written not by physics, but by fear. And then there was the darker interpretation, that intelligence is not rare nor silent, but fragile. Civilizations may bloom and vanish, their beacons too brief to catch, their lifespans dwarfed by cosmic time. The silence could be the sound of extinction repeated across the galaxy. The atmosphere of this world might not be sustained by thriving life, but by the remnants of a biosphere long past its peak, a planet breathing out of memory rather than present vitality. Each possibility deepened the mystery, raising not only scientific questions, but philosophical ones. If life is common, but intelligence is rare, what does that mean for humanity's future? If intelligence hides, what dangers does it hide from? If intelligence is fragile, what fate awaits us? The rising probability, 99.7%, became not just a number, but a mirror, reflecting humanity's own uncertainties. It revealed not only what might be on that distant world, but what might await on this one. For every data point about methane and oxygen was also a question about survival, about destiny, about whether life is a fleeting accident or a universal pattern. As Webb continued to watch, the weight of discovery grew heavier. Astronomers spoke in measured tones, but in private, many admitted the strangeness of their position. They stood on the verge of perhaps the greatest revelation in human history, yet held back by caution, by the knowledge that one misstep could shatter credibility. To claim life where none exists would be catastrophic. To remain silent in the face of life would be equally so. Thus, the planet remained a paradox, its probability near certainty, its silence near complete. Each analysis confirmed the gases, each model strained to explain them away, and yet the conclusion hovered just out of reach. The universe had shown its hand, but not its intent. In the stillness of deep space, the mystery deepened.
At humanity,
with its golden telescope poised at the edge of the dark, found itself staring not at emptiness, but at a reflection of its own longing, a world alive yet mute. A probability so high it approached destiny, yet a silence so profound it felt like a warning. And so the tension grew, suspended between wonder and dread. The planet, circling its quiet star, kept breathing in chemistry, kept whispering in spectra, kept offering science the certainty of numbers but withholding the comfort of answers. It was the escalation of mystery, not its resolution. A reminder that the universe, when it reveals itself, does so not in absolutes, but in paradoxes. Life almost certain, yet unseen. Silence, almost total, yet speaking volumes. And humanity, caught in the middle, left to wonder whether it was witnessing a beginning, an echo, or a fate. The discovery of strange chemistry in a distant atmosphere is not an ending but a doorway. Behind it lies a chamber filled with questions, and through those questions the human mind cannot resist wandering. Each molecule, each imbalance of gases, is a clue, but clues do not tell their story plainly. They require interpretation, and interpretation is always shadowed by speculation. The first explanations are cautious. Abiotic processes. They are called the workings of a planet without work. Life, carving signals that only mimic biology. Methane, for instance, can emerge from the fractures of a world's crust. Deep beneath the surface, water and rock can conspire under heat and pressure to forge hydrocarbons, venting them upward into the sky. Carbon dioxide may rise in plumes from volcanic calderas, reshaping the air without a single breath of life. Even oxygen, the great marker of photosynthesis, can be born in the absence of plants, split from water molecules by the relentless gaze of a star. Photolysis, driven by ultraviolet light, can fill an atmosphere with false hope. Scientists have seen such illusions before. Titan. Saturn's moon harbors seas of methane and nitrogen haze, sculpted by chemistry alone. Venus once lured dreamers with its cloud-shrouded silhouette, only to reveal an oven of carbon dioxide and sulfur. To assume life too quickly is to risk repeating these mistakes. And so the first theory that exotic lifeless chemistry is at work must be tested and retested, till every alternative has been exhausted. Yet the mixture of gases on this planet does not yield easily to such explanations. Methane and oxygen, side by side, should devour each other swiftly. Their coexistence suggests replenishment, a steady source feeding them into balance. Carbon dioxide threads through the spectrum not as a dominant tyrant, but as a subtle companion. And water vapor floats above it all, hinting at oceans or clouds below. Together, the chemistry resists the cold comfort of geology alone. It is as though the atmosphere itself is restless, refusing to settle into lifeless equilibrium. The second theory turns to life in its simplest form. Perhaps the planet is not a civilization, not a beacon, but an ocean world rich with microbial blooms. On Earth, for nearly 3 billion years, life consisted only of cells too small to see, drifting in tides, covering rocks in films, exhaling gases into the air and sea. The great oxidation event, which filled Earth's sky with oxygen, was the work of cyanobacteria, not of civilizations. If Webb's telescope has captured a similar moment, then this world may be an echo of Earth's deep past. Primitive, thriving, invisible. A world alive, not with voices, but with breath. This possibility carries its own wonder, for it suggests that life is not a rare accident, but a natural outcome of planetary chemistry. Give a world oceans, warmth, and time, and cells may emerge feeding on sunlight or minerals. Weaving themselves into ecosystems, such life would not yet build cities or transmit signals, but it would still be profound proof that biology can emerge wherever the conditions allow. A universal rhythm of molecules learning to organize, to persist, to evolve, and yet there lingers the third speculation, the most unsettling of all. What if the planet is not voiceless by nature, but by choice? If civilizations arise elsewhere, they may learn what humanity is only beginning to grasp, that the universe is vast, but not necessarily welcoming. Broadcasting into the dark may be unwise. Silence may be survival. The absence of radio signals may not mean absence of intelligence, but presence of caution. Civilization advanced enough to shape its skies could also be advanced enough to hide. This notion sharpens the Fermi paradox into something far more personal. Enrico Fermi once asked, "Where is everybody?" The question implied absence. But perhaps the answer is different. Perhaps everybody is there, watching, listening, waiting. So, then the paradox is not a void, but a veil. A universe of life, cloaked in deliberate quiet. Other speculations grow darker still. Civilizations may not endure. They may rise briefly, altering their worlds, leaving behind atmospheric scars that persist long after their voices have vanished. Telescopes may see the breath of life, but not its song, because the singers are gone. The gases may be a memorial, not a message. A warning that survival is fragile, that intelligence is a candle flickering against the winds of time. Philosophers and scientists alike have wondered whether this is Earth's reflection, a glimpse not only of possibility, but of fate. Humanity can look across the stars and see a world caught in silence. What does that say about its own chances of endurance? Does life inevitably fall before it learns to last? Or does silence conceal civilizations too wise to announce themselves? Another possibility, more ancient and speculative, stretches beyond a single planet. Panspermia, the theory of life spread across worlds, suggests that biology may not begin anew each time, but may travel. Microbes hardy and resilient can survive in rock fragments blasted from planets by impacts, drifting for eons before falling into new atmospheres. If so, then perhaps this world and Earth are not strangers at all, but distant cousins, seeded by the same cosmic event. Life, under this vision, is a traveler, scattering across the galaxy like pollen on the wind, planting itself wherever it finds fertile ground. The idea is both humbling and exhilarating. If panspermia is true, then life's roots are deeper than Earth, its origins stretching into the very fabric of the galaxy. The gases Webb has seen may not only be evidence of biology, but evidence of kinship. A reminder that the spark of life does not belong to one planet alone, but to the cosmos itself. In the halls of science, each of these theories is weighed with care. The abiotic explanations are modeled, their limits tested. The microbial vision is explored, calibrated against what is known of Earth's early eons. The idea of hidden civilizations remains speculative, but not dismissed. The paradox of silence is sharpened by data, no longer a thought experiment, but a confrontation with evidence. And panspermia remains a possibility that connects geology and astronomy in a single story. What unites them all is the realization that Webb's discovery is not merely about a planet, it is about the nature of life itself. Is it rare? Fragile, a miracle confined to Earth? Or is it common, inevitable, seated across the stars? Is intelligence the exception or the rule? Is silence the sound of absence or the mask of presence? The theories are many, but beneath them lies a single truth. The universe has spoken, not in words, but in chemistry. It has shown a planet breathing against the odds, and it has left humanity to interpret the meaning. The speculation does not resolve the mystery, it deepens it. For each theory carries not only science, but philosophy, reflection, even warning. Perhaps the planet is alive with microbes. Perhaps it hides a civilization in quiet restraint. Perhaps it is the echo of a life that once was, or the sibling of our own biology scattered across the stars. Whatever the answer, the discovery demands humility. The Golden Telescope, adrift in the darkness beyond Earth, has forced humanity to confront possibilities larger than itself. It has shown that certainty may be forever elusive, that the line between illusion and truth may blur. But it has also shown that the universe is not indifferent. It is speaking in gases, in probabilities, in whispers written into light. And so the theories remain, suspended like constellations in the mind. Abiotic chemistry, microbial oceans, hidden civilizations, ancient panspermia, civilizations gone before their time. Each possibility both a story of another world and a mirror for our own. The planet continues to orbit its star, its atmosphere shimmering in spectra, its silence echoing across the void. And humanity, with its questions and fears and wonder, continues to listen. The search for life is not a single revelation. It is a patient unfolding, a rhythm of observation and confirmation, of doubt and verification. The James Webb Space Telescope, humanity's golden eye adrift 1 million miles from Earth, continues its vigil over the star and its enigmatic world. With every orbit, with every transit, the planet offers another chance to be studied, and Webb listens with unwavering attention. Its instruments are designed not only for first glimpses, but for long endurance. Webb returns to the same star again and again, tracking the subtle dimming as the planet crosses its face. Each crossing is a fingerprint. Each fingerprint, another chance to refine the atmosphere's portrait. The telescope does not see oceans or forests, but it can sense their shadows written into light. By measuring seasonal variations, subtle shifts in gases, or the presence of clouds drifting in alien skies, it can begin to sketch not only what is there, but how it changes across time. The data gathered is fragile. It is not a picture, but a spectrum. Tiny variations in brightness and color, filtered through instruments of extraordinary precision. To ensure that no illusion creeps into the story, the information is tested and retested. Independent teams, scattered across continents, download the raw signals, strip them of noise, and build models to see if the gases persist. The work is cautious, sometimes painfully slow, because one false claim could unravel decades of credibility. Science demands patience, and patience is the price of truth. But Webb is only the beginning. New giants are being prepared. The extremely large telescope, rising in the dry air of Chile's Atacama Desert, will carry a mirror 13.9 meters wide, capable of piercing the skies with a clarity no human eye has ever known. Its instruments will attempt what Webb cannot, to separate the faint glow of a planet from the overwhelming blaze of its star. To directly capture light reflected from alien worlds, beyond Earth's surface, space agencies dream of successors. To Webb LUVOIR, the large ultraviolet optical infrared surveyor, is envisioned as a cathedral of mirrors. Vast enough to directly image Earth-like planets around distant stars, HABEX, the Habitable Exoplanet Observatory, is designed with a single purpose: to search for signs of life. It would fly alongside a starshade, a vast unfolding disk meant to block starlight and let the faint shimmer of planets emerge. These missions are still visions, bound by budgets and decades, but they hold the promise of transforming hints into certainties. Together, they represent humanity's next great leap from detecting atmospheres to studying surfaces. Scientists speak of future telescopes not just discerning gases, but clouds, oceans, even continents. Patterns of vegetation might one day be seen in the changing colors of a planet across its orbit. Weather systems could be tracked as storms circle alien skies. The idea that one day humanity might watch rain fall on another world is no longer only poetry. It is the logical consequence of technology advancing along its relentless path. Still, further lies the dream of contact, more tangible than light. Across centuries, thinkers have imagined sending probes to distant stars. The distances are merciless. Even the nearest systems are light years away, requiring tens of thousands of years. With present propulsion, yet visions persist. Concepts like breakthrough starshot imagine fleets of tiny sails pushed by lasers to a fraction of light speed, crossing the void in decades rather than millennia. Such ideas strain the limits of engineering and physics, yet they remind humanity that today's impossibility may be tomorrow's endeavor. For now, the focus remains on what can be reached. Webb, ELT, LUVOIR, HABEX, each tool is a stepping stone, each mission a bridge. The process is deliberate, unfolding not in a single moment, but in decades of cumulative effort. Every dataset is archived, shared, open to scrutiny by scientists. Across the world, transparency is the shield against error, collaboration the engine of progress, and so the investigation continues. Webb refines the spectrum, measuring the faintest breaths of atmosphere. Earthbound telescopes prepare to capture the first direct images. Space agencies design the instruments that will one day reveal surfaces, oceans, perhaps even the rhythms of weather on alien shores. Humanity watches, waits, and dreams. Yet beneath the precision of science, a deeper reflection lingers. Each advancement brings us closer not only to knowledge, but to confrontation with a truth we may not be ready to bear. To see a planet's surface, to map its weather, to confirm life, these are not merely scientific achievements. They're existential thresholds. The tools are built of metal and glass, but what they reveal will be measured in wonder, and perhaps in fear. The possibility of sending probes across the Gulf remains a dream, a project for centuries yet to come. But already the path is clear. Each telescope is a ship, not of matter, but of vision, carrying human curiosity across the void. Each spectrum is a landing, each confirmation a footprint, not on alien soil, but on the edge of understanding. In the decades to come, humanity may look at a planet and see more than chemistry. It may see clouds gathering over an ocean, seasons shifting on distant continents, storms that rise and fade like the pulse of a living world. That future is not fantasy, 'tis waiting, written into the designs of telescopes still on drawing boards, waiting for hands to build them, for eyes to look through them, for minds to interpret what they reveal. And so, the work continues. Disciplined and patient, humble before the enormity of its task, the golden telescope keeps watch. The next generation waits in blueprint. The future stretches forward, a chain of instruments reaching deeper into the dark. What began as a spectrum may one day become a vision. What began as probability may one day become certainty. And what began as a whisper of chemistry may one day become the voice of another world. When the data first emerged, it was contained within narrow circles of expertise. Research groups compared notes, institutions debated, peer review sharpened the claims. Yet news of a planet with a 99.7% chance of life could not remain confined to the cloisters of science. It slipped outward, crossing borders, spilling into media, politics, religion, and culture. The numbers traveled faster than light itself, igniting imaginations long prepared for such a revelation. Headlines declared it the greatest discovery in history. Images of the planet, artistic renderings, not photographs, filled screens and papers. Oceans imagined in deep blues, continents draped in clouds, skies painted with alien suns. The public was not deterred by the caution of scientists. The statistical whisper became, in their eyes, confirmation. Humanity, they said, was no longer alone. Politicians seized the language of destiny. Some spoke of funding new space programs, urging exploration not only of the moon or Mars but of distant stars. Others framed the discovery in terms of power, warning that to lead in science was to lead in history. International debates emerged, not over whether life existed, but over who would first claim the prestige of proving it. Religious voices, too, rose in response. For some, the discovery was affirmation. If life was abundant, then creation was vaster than imagined, a testament to divinity expressed across the cosmos. Theologians spoke of other flocks, other worlds under the same cosmic shepherd. Yet others felt unease, for a universe filled with life seemed to decentralize humanity, to strip Earth of its privileged stage. Ancient texts were reread, ancient meanings reshaped. As faith sought to encompass a reality wider than before, culture absorbed the news with a blend of awe and anxiety. Artists filled canvases with imagined landscapes, musicians wrote symphonies, echoing with alien winds. Filmmakers crafted stories of contact and consequence. Yet alongside wonder came fear. For if life was out there, what form did it take? Is it microbial and harmless, or intelligent and indifferent? Fiction reached for both hope and dread, mirroring the dual heart of humanity's reaction. Psychologists noted the tremor beneath the enthusiasm. For centuries, Earth had been humanity's singular sanctuary, the only known cradle of life. Now, with one planetary spectrum, that uniqueness was shaken. To be singular is to be precious, but to be one among many is to be ordinary. Some welcomed the ordinariness, comforted by the thought that life is not a fragile accident. Others recoiled, unsettled by the loss of cosmic centrality. Identity itself seemed to shift, not through conquest or revolution, but through the quiet revelation of chemistry. The scientists who first studied the data found themselves in a strange position. They urged caution, refusing to declare life confirmed. They spoke of uncertainties, of possible false positives, of the need for further observation. Yet their words were often drowned by the world's hunger for wonder. To the public, 99.7% was not cautioned. It was certainty disguised as modesty, this tension between scientific restraint and public celebration. came the defining note of the human reaction. Conferences filled with debates over phrasing. Is it probable life, possible biosignatures, or strong evidence of biological activity? Each term was weighed, each syllable contested, because words had power beyond data. To declare life where there was none would be catastrophic. To withhold acknowledgement if life was real would be equally unforgivable. As the debates continued, the world leaned into its own interpretations. For some, the discovery was hope. If life was elsewhere, then perhaps humanity's struggles were not unique. Perhaps intelligence, cooperation, even survival were shared challenges across the stars. For others, it was threat. If life was common, then so too might be competition, conflict, or predators unseen. Awe and fear walked hand in hand, neither able to outpace the other. Philosophers reflected on the paradox of discovery. To confirm life beyond Earth would be to answer one of humanity's oldest questions, but it would also open new ones. What rights does alien life have? What responsibilities does humanity bear toward it?
Yes.
If microbes thrive on a distant planet, should they be left untouched or studied as keys to biology itself? If civilizations hide in silence, should humanity call out louder or learn to keep its own silence? The human reaction was not a single voice, but a chorus. Some sang of triumph, others of humility, still others of dread. The discovery revealed less about the planet itself and more about humanity, its hopes, its fears, its hunger for connection, and its fear of insignificance. Through it all, the planet remained unchanged, circling its quiet star breathing its silent gases into space. The human response unfolded not from the world itself, but from what it symbolized. It was a mirror, reflecting humanity's longing to be accompanied, and its fear that companionship may come at a cost. And so the world continued to watch, torn between wonder and worry. The discovery of biosignatures was a scientific milestone, but its deepest impact lay within the human heart. For in that distant atmosphere, humanity glimpsed not only the possibility of another life, but the fragile balance of its own. To gaze at a distant world and glimpse the breath of life in its atmosphere is to confront a mirror across light years. Chemistry speaks in silence, yet within that silence, humanity hears its own reflection. Oxygen, methane, carbon dioxide. Water vapor molecules that shaped Earth's story, now etched in the spectrum of another planet. They are not proof, not certainty, but resonance. A pattern that feels familiar, a rhythm that reminds us that perhaps the song of life is not ours alone. Science does not trade in absolutes, it speaks in probabilities, in confidence intervals, in the fragile precision of data tested and retested. 99.7% is not a declaration of truth, but it is enough to tremble the foundations of philosophy. For while mathematics may leave a margin for error, the human soul does not. To see even the chance of life elsewhere is to feel the universe shift beneath us. The fragility of certainty becomes part of the reflection. We are reminded that knowledge is always incomplete, that answers come in shades, not absolutes. Yet, paradoxically, even a probability can be enough to transform. A whisper of life, carried in light, alters how humanity perceives itself, no longer singular. No longer perhaps the only voice in a vast and ancient dark. This realization carries both wonder and unease. Loneliness has long been the default posture of our species. We build myths and religions, philosophies and sciences upon the assumption of solitude. The earth is fragile yet unique. Humanity is small yet central to its own story. Now, with spectra of a distant sky, loneliness is called into question. If life is there, then companionship is possible. If life is common, then solitude is illusion. Connection becomes the haunting possibility. To imagine another world where oceans breathe, where air is restless with chemistry, is to imagine that humanity's story is not exceptional but shared. Perhaps life is the rule, not the exception, the consequence of physics unfolding with patience. So, then the universe is not indifferent emptiness, but a web of living worlds, strung across stars like beads of possibility. and yet connection brings its shadow. For if life is abundant, why is it silent? The paradox lingers, deepened by each discovery. Perhaps life thrives in oceans and soils, but rarely climbs into the stars. Perhaps civilizations rise and fall, too brief to bridge the abyss. Or perhaps they choose silence, waiting, watching, concealing themselves beneath the veil of chemistry. Humanity, in its first steps outward, cannot know. But even without answers, the reflection matters. To see life's signature elsewhere is to see Earth anew. Our atmosphere, too, is a fragile imbalance, sustained by forests, oceans, and the breath of countless organisms. To recognize the same pattern elsewhere is to understand how delicate it is here. The gases that speak of life also speak of vulnerability. The mirror does not only show possibility, it shows responsibility. In this moment, the James Webb Space Telescope becomes more than an instrument. Its golden mirrors, stretched like petals into the void, become the eyes of a species, staring into the abyss and finding not emptiness, but resonance. Humanity's longing, doubt, and wonder are caught in those mirrors, sent outward to meet the light of another star. Then returned, transformed, the emotional weight of this discovery lies not in certainty, but in possibility. To live with the knowledge that we may not be alone is to inhabit a universe wider than imagination. It changes prayer and poetry, ambition and fear. It asks us to see ourselves not as the center, but as one note in a cosmic chorus. And perhaps that is the final lesson. The silence of the cosmos is not proof of absence, but a reminder of patience. Stars burn for billions of years. Life takes eons to rise, and longer still to speak. The universe is vast beyond reckoning, and humanity's listening has only just begun. So the telescope keeps its vigil. Light continues to arrive, whispering of oceans unseen, skies unbreathed, companions unmet. And humanity, fragile, yearning, listens. Perhaps the silence of the cosmos is not absence, but waiting,